Welcome to a lesson with Dr. Powell. Let's take a look at finding the power series representation of this function centered at 0. If we had f of x equals this um, as a function. So what's this power series? So, well, this is related to a geometric series. We think about taking the antiderivative of this, setting u is equal to that, if we will, and realizing the derivative of u is -1. So we're going to have a negative out here. I think of this as like u to the -2. So antiderivative would be like u to the -1. So it'd be on the bottom, 1 minus x, but then we have a negative. It's a double negative because the derivative of this is negative, and then we have our power is -1 that we're dividing by. So we just end up getting that. So the antiderivative 1 over quantity 1 minus x squared is this. So antiderivative. So we took an antiderivative, and this is a particular antiderivative. If we just let the plus c be 0 right here, that's fine. Okay, so we take this and we realize that this is a power series. This is n equals 0 to infinity of x to the n. And now, to go backwards, we need to take a derivative of this. Now, this is nice because whatever plus c we had over here would go away in this derivative process. That's why we don't really need it here. So we go backwards. Now, in going backwards, we take a derivative term by term. So derivative of x to the n, and is a constant, that's simply n x to the n minus 1. But notice that we lose an index because the index at 0 just gives you a 1. X to 0 is 1. And so when you take a derivative, that constant goes away. And these powers have gone down 1. So really, the sum is really starting at 1 now. So when you take a derivative, you actually lose your first index. If you're starting at a power of 0, then you're going to lose that because you're going to lose your constant here. And notice this works out. You can try it. If you plug in 1 here, you have x to 0, so you know you're starting at a constant. That's good. Okay. And these two will actually be equal then, since their derivatives will match, because the two because we took an antiderivative and then we just took its derivative, and we should get back to the same place. So we have this is actually equal. You had to just think about that index for a minute, but it was okay. And we just discovered the formula for this as a power series, and it works in the radius. It works on the interval of convergence for this series right here. Thanks for watching.